Good morning, students. Today we are going to study about the magnetic effect of what? The electric current. So I want to solve the two questions. Okay, I have already written on the board. Let us consider the first question. So here we have the first question. List two methods of producing magnetic field. So you require to list the method of producing a magnetic field. How you are going to produce a magnetic field. So the one important thing is that take one ball magnet. Okay. So here is the ball magnet. So let us consider here is the north pole and this one is the south. Around this particular magnet, what is present? There is a magnetic field. Okay. So here we have what here? The magnetic field around it. Okay. So I am showing the magnetic field lines, the arrangement of magnetic field lines. It is just like this. It looks like starting from the north and ends in about here the south. So this is what the magnetic field. The first and foremost thing, by using a what here, the ball magnet, or we can just say magnets. By using a what here, the magnet can produce a what here, magnetic field. And what is the second one? The second one, you already know that a straight wire carrying a water current. A straight wire carrying a current. Let us consider, here is a wire. It is carrying a current. So there is a flow of current is there here. Okay. So like this. Positive, this side is what here? Negative. Key. This is the minus, this one is the plus. A, B. A, B I will just mention as a what here? A conductor, a straight conductor, a straight wire we can say. So around this, what is present over here? So there must be a what here? Magnetic field around it. There is the presence of what here? Magnetic field. So what is the second thing is that? A straight conductor carrying a water current. Okay, current I. Straight conductor, or we can say wire carrying what? Current I. Then we can produce around that conductor, there must be a presence of water, magnetic field. And there are other thing is also there, circular coil. So we can able to say what here? A circular coil carrying water, current again. So the last time we had done this one, okay, a circular coil, okay, or a loop, or a circular coil. Circular coil is like this, okay. So here this also produces a what here, around that it will produce a what here, so magnetic field around it. So these are the list two, we can take a two methods of it, whether you are using a ball magnet, whether you are using a what here, a straight conductor carrying the current, or we can say a circular coil carrying what here? Current. So these are the methods we have. Understood? Let us pass on to the next question. How does the solenoid behaves like a magnet? This is the first part of the question. How does the solenoid behaves like a magnet? Okay. Consider a one solenoid which carrying a what here? Current. Okay, here is carrying a what? So here is a solenoid. So suspend that particular solenoid carrying a what here? Current. So here is the solenoid. Number of rotations are there. Here the current is the passing through. So it is always stood in the position of what here? North, and also another one is what here? South direction. Whenever it stands in the position of what here? The north and the south direction, then it behaves as a what here? The magnets also stand in the position of what here? North and the south direction. So that is why we can able to consider a solenoid is also behaves like a what here? Magnet. And there is another thing is also there. We can put a magnetic iron filings near to this, it will attract. Whenever it is attracts, then we can say like that. It behaves like a water magnet. Then what is the second part of the question? Can you determine the north-south poles of a current carrying what? Solenoid. I want which is the north and which is the south. I don't know this one, which one is the north and which one is the what here? A south direction. So I don't know this one, this is the north, I don't know, this one is the south, I don't know. Okay. I want to identify which is the north and which is the south. Take a one bar magnet. Okay, just take a hand this the solenoid. Okay. Then afterwards take a one what here? One bar magnet. Just this is the bar magnet. Keep the south end of the bar magnet. It is already mentioned because one side is dot is there. Whether there is a dot is there in a bar magnet, it is always predetermined. Predetermined north is always be there. Okay, there is a dot is there in usually in magnets. That is considered as what here? North pole. So north, and bring a south pole of this magnet, this bar magnet, near to the water. Conductor, this means solenoid, which is carrying a water, a current. What happens to this? If the solenoid just it is attracts, whenever it is attracts, come near and nearer to it, then you can consider it as what here? North, because the unlike poles are what happens here? Attracts. Whenever it is moves away, then I can able to consider this one as what here? South. Okay. Whenever it is attracts, so I can able to say this is the north end, this one is the what here? South. Whenever it is ripples, okay, here is an attraction is there. Whenever it is a ripples like this, okay, then I can consider this one as what here? South, and this one is the north, and this one is what here? So this is how we can able to identify the what here? So the solenoids north and also what is that? South. So these are the two questions are very important. Please follow this. Okay. Thank you very much.